Imagine two LEDs blinking back and forth in perfect rhythm like a heartbeat made of light. One turns on while the other switches off, creating that classic alternating flasher effect you see in warning lights, indicators, and DIY electronics projects. Hey guys, in this video I'll show you how to make a dual flasher circuit with a 555 timer and a few components. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 7 jumper wires, 1 220 ohm resistor, 1 kilo ohm resistor, 2 1N4007 rectifier diodes, 2 LEDs, 1 100 microfarad capacitor, a battery holder with 4 AA batteries for the power source, 1 555 timer IC, 1 10 kilo ohm potentiometer, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and astable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Use a jumper wire to connect pin 4 or reset to pin 8 or VCC. Insert a 100 microfarad capacitor into pin 2 or trigger in the negative rail. The anode is in pin 2. Bend the ends of a 1 kilo ohm resistor. Insert a 1 kilo ohm resistor to pin 7 or discharge and the positive rail. Insert a jumper wire into pin 7 or discharge and a few rows below the 555. Insert a jumper wire into pin 6 or threshold and 2 rows above the previous jumper wire. Insert a jumper wire into pin 6 or threshold and 2 rows above the previous jumper wire. Insert a 10 kilo ohm potentiometer into the same rows as the 3 jumper wires. Bend the ends of a 220 ohm resistor. Insert the 220 ohm resistor to pin 3 or output in a few rows below the 555. Insert the 1 N4007 rectifier diode into the same row as the resistor and a few rows below the resistor. The anode is in the same row as the resistor. Insert a red LED into the same row as the diode and the negative rail. The cathode is in the negative rail. Insert the 1 N4007 rectifier diode into the same row as the resistor and a few rows below the resistor. The cathode is in the same row as the resistor. Insert a blue LED into the same row as the diode and the positive rail. The anode is in the positive rail. It's time to connect the power supply. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. We have successfully completed the circuit. Rotate the potentiometer knob to decrease the flashing speed. Let's dive into the circuit and break it down step by step. This circuit is a 555 timer Astable oscillator driving a pair of alternating LEDs, which is why it's called a dual flasher. The 555 timer is powered from a 6-volt battery. Pin 8 or VCC goes to the 6-volt battery and pin 1 goes to ground. Pin 4 or reset is tied directly to VCC, so the chip is never held in reset and can oscillate freely. R1, R2, and C1 form a charge and discharge path for the capacitor. Pin 2 or trigger and pin 6 or threshold are tied together, so the 555 constantly monitors the capacitor voltage. Pin 7 or discharge connects to the junction between R1 and R2. Inside the 555, there's a transistor on pin 7 that either releases this node so the capacitor can charge, or pulls it hard to ground so the capacitor can discharge. When the output at pin 3 is high, the discharge transistor is off, and C1 charges from VCC through R1 and R2 toward the 6 volts. As C1 charges, its voltage rises. When it reaches 2/3 VCC, the upper comparator trips. The flip-flop inside the 555 changes state. The output at pin 3 goes low, and the discharge transistor on pin 7 turns on. Now C1 discharges back towards 0 volt through R2 into pin 7. When the voltage on C1 falls below 1/3 VCC, the lower comparator trips. The flip-flop switches again, pin 3 goes high, pin 7 turns off, and the cycle repeats. This constant charging and discharging of C1 between 1/3 and 2/3 of the supply creates a continuous waveform at pin 3. The values of R1, R2, and C1 determine the flashing rate. Increasing the value of R2 or C1 makes the capacitor charge and discharge more slowly, which causes the LEDs to blink more slowly. Decreasing these values shortens the charge and discharge time, so the blinking speed increases. Because R2 is a potentiometer, turning its knob changes the total resistance in the timing path and gives you an adjustable flash speed. Pin 3 or output connected to R3, a 220 ohm resistor that limits the current flowing through the LEDs and protects them from damage. R3 is connected to the junction between 2 diode branches. D1 and D2 are connected toward the positive rail, and D3 and D4 are connected toward ground. These diodes are arranged so that only one branch conducts at a time, depending on whether the output is high or low. When the output at pin 3 goes high or near 6 volts, the branch containing D3 and D4 becomes forward biased. Current flows from pin 3 through R3, then through D3 and D4 to ground, causing D4 to light up. During this condition, the branch with D1 and D2 is reverse biased, so it remains off. When the output switches low or near 0 volt, the polarity across the branches reverses. Current now flows from the positive supply through D1 and D2, then through R3 into the low output at pin 3, which turns on D1 while the lower branch is turned off. As the 555 timer continuously toggles between high and low states, the circuit alternates conduction between the two branches, producing the dual flashing effect. I hope this video has shown you how to make a dual flasher circuit with a 555 timer. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Just click the link in the description to download your copy now. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.